All right, lesson 5 of Unit 2, Topic 1, and this lesson is about functions, determining if something is a function or not, and it's also going to look more into domains and ranges. So this warm-up is exactly just that. So let's determine what is the domain and what is the range. What is a domain? Domain is just a list of all the possible x's. All right, so usually I put brackets, but you know what? For the time being, I'm just going to list the numbers because there is already a box to write in. So I'm just going to list all the numbers right here. So we got -7 is the first x, then 3, and then 8. Don't forget to have your commas because otherwise you won't be able to tell the numbers apart. -6 and -2. All right, and then the range is just a list of all the possible y's. You've got 2, 5, 4, 5 again, so I'm not going to repeat, and 3. So those are all the possible answers for y's. Now, usually you want to put them in order from least to greatest, but in the time being, it's really not wrong if you don't put them in order from least to greatest. So is this a function? Is this relation a function? There's 4 ways to write a relation. You can be a mapping, a table, a graph, or a set of ordered pairs. This happens to be a set of ordered pairs. I notice that all of the x's are all different, so therefore this is a function because no domain has more than one range. -7 has one range, 3 has one range, 8 has one range, -6 has one range, -2 has one range. None of the numbers repeated in the x, so therefore they don't have 2 different ranges. All right, for the next one, this has got 9, 0, 4, 5, 2, 0 again, and 3. And that's kind of a giveaway that this is going to be no, and I'll talk about that in a second. So ranges can be 2, 4, 0, 3, 7, -3, and 1. All right, so the reason why I said that this is no is because this ordered pair and this ordered pair, the domain of 0 has 2 different answers for the range. So therefore, this is not a function because each domain is only allowed to have one range. It does not matter if any of the y's repeat. It's only if the x's repeat. So the next one is also going to be a function. The domains are 1, 2, 3, and 4. And the ranges are 7, 0, 9, and 4. All right, so that was pretty easy because 1 only has one range, so does 2, so does 3, so does 4. All right, so let's get to the lesson. In this lesson, you're going to be able to determine whether something is a function or not. And you're going to start off with this activity of Gavin the Great. Gavin has a 40-foot piece of rope, and he's a magician, and he wants to cut it in half. So if he cuts it 0 times, his rope is 40 feet long. If he cuts it 1 time, he cuts it in half, it's only 20 feet long. If it's cuts it twice, it's going to be 10 feet long, and 3 times, it's going to be 5. 4, it's going to be 2.5, and that pattern can continue forever. So that's called a mapping. A mapping shows a relation, which this is, how x's and y's are related to each other, and you just put an arrow from the x to the y, and it's just a pretty basic mapping that each domain is going straight across to one range. It doesn't always go like that. So the graphing the results, so if each number was 5, 5, 10, 15, 20, 25, 30, 35, 40, 0 cuts is 40, 1 cut is 20, 2 cuts is 10, 3 cuts is 5, 4 cuts is 2.5, 6 cuts would be 1 1/4, and then you can kind of see that the graph is going to go like this. It's called an inverse variation. An inverse variation means that as x increases, the y decreases, and it decreases proportionally. All right, so this is inverse variation. Inverse variations always go down like this, and you might learn in Algebra 2, this is called an asymptote. The asymptote, yeah, I know, that's a weird word, is the line in which it'll never hit. You can cut a rope in half as many times as you want, and it will never be nothing. You'll never hit 0. So 0 is what we call the asymptote of the function. Asymptote is basically a fancy word for saying the line in which it'll never hit. And then in Algebra 2, you'll get asymptotes that are not just 0. They can be actually any number. Set of ordered pairs, I would just simply do something like this. If it's 1 cut, it's 20, and so forth, and you would keep going. All right, same with the table. 0, 40, 1, 20, 2, 10. These are all the 4 ways of writing a relation. So that's what that warm-up was. That was basically a practice. All right, so now here's the real lesson part itself. So determining if each of these is a function or not. And in order for it to be a function, one has to be dependent upon the other. And each answer can only have one result. A person's name versus their social security number. A person's social security number is dependent upon a person's name. No, that's not true. A person's name depends on its social security number. And each person can only have one social security number. So, a person's name is dependent upon their social security number. And once again, each person's name can only have one social security number. Oh, as I'm thinking through this, that is incorrect, because I guess technically two people could have the exact same name. So if two people have the same name, then that name could have more than one social security number. Unless you're thinking of the other way around, because it's kind of hard to determine which is dependent upon which. If you say social security number can only have one name to it, then you're saying that a name is dependent upon their social security number. Okay, that would make sense. And therefore, each social security number can only have one name, and therefore that is a function. Okay, so that's a better way of looking at it. I'm glad I thought that question through. Some of these questions can be a little bit tricky, as I just thought that one through. A person's social security number versus their name. Okay, so that's kind of the same question, but I am now forgetting the fact that that's what threw me off in the first question, that a functional statement is always the dependent is a function of the independent. So a person's social security number versus their name, so that means that's the dependent and that is the independent. So if the independent is the name, can a name only have one social security number? No. So this one is not a function. And the reason being is because in this example, a name can have more than one social security number, because you can have two people with the exact same name, as I described in the previous. I just kind of lucked out that this one was correct. The cost of gas versus the amount of gas pumped. So is the cost of the gas is dependent upon the amount of gas pumped. That's a true statement. Can you pump two different amounts of gas and cost two different amounts? I think yes. This is kind of a debatable question here, though, because I think that you can get three different types of gas. You can get regular, you can get medium grade, and you get the supreme, and therefore this is not a function, because you can have three different total costs even though you get the same amount of gas. This one, pretty basic, pretty easy. That one is a function because each of the domains doesn't repeat. The temperature in degrees Fahrenheit with respect to time of the day. So the degrees is dependent upon the time of day. Can a time of day have more than one temperature? No. Function. Definitely. This one, not a function. And the reason why it's not a function is because of these 2 points right here. 6 cannot have two different ranges. 7, the area of a circle as it relates to the radius. Does the area depend upon the radius of a circle? Yes. Okay, so far that makes sense. So can a radius have more than one area? No. It can only have one area, so therefore that is a function. Yes, it sure is. Justification I just said. This one, function. Yes. Definitely, because each domain only has one range. The radius of a circle is dependent upon its volume. So we're saying the radius of a cylinder is dependent upon the volume it holds. Well, actually, it kind of depends on how tall the cylinder is. So, can a volume have more than one radius? Yes, so that's not a function, because it can have more than one answer. It can have two answers, it can have three answers, it can have an infinite amount of answers, because the cylinder could be any size tall, giving you many different answers. 10. The size of a radius of a circle is dependent upon the area. So the size of a radius is dependent upon the area. That does make sense. The size of the radius depends upon the area of a circle, yeah, because that can only have one answer. Can an area have more than one radius? If it's a circle, no. So that is a function, yes. Actually, that's one of those rare cases where that works both ways, no matter which way you write it. A student's letter grade dependent upon a percent earned. Well, that's true, okay. So can a percent have more than one letter grade? No. You can only have, if you get an 89%, you definitely get a B. There's no other option. So each domain can only have one range. That is a function, yes. The length of a fence needed with respect to the amount of area to be enclosed. The length of the fence is dependent upon the area. Can an area have two different lengths? These two rectangles can have the same area but have two different size lengths, so therefore this is not a function. You can have a really skinny fence and a really fat wide fence, and they'll have the same area, but this one requires less fencing than this one. This one will require more fencing. So therefore that answer is no, it's not a function, because an area can have two different lengths. Alright, I'm going to skip this page because this is going to be those challenge questions that we talked about in class. This one's definitely a function. This one just means that it's increasing by 4. So if you start with the first number at 3 and it's increasing by 4, I know I said I was going to skip it, but I love going over recursive stuff. So that one, if it's increasing by 4, no answer can have more than one answer, so therefore that is a function. Yes, it is. Alright, I'm going to move on. So, further representation of this function given, determine if the domain and range. Alright, here's the homework that everybody's been waiting for. What is the domain of this function? Alright, this is a cubic function, and the answer is going to be a domain. That's irrelevant. We'll do that later on. So the domain starts at 1, and then it ends infinitely. So I am going to erase what I just did because there is no end to this. So the domain is just that x can be greater than or equal to 1. And why it's or equal to? Because of that dot. It's a closed dot. The range. Range means how high is it. So this graph starts with a height of 0. And once again, I don't like the way I'm writing this because it's not going to be a compound inequality. And the range can be anything above 0. Y can be, or f of x technically, I guess, because that's what the graph says. F of x can be anything above 0. Because technically this will go infinitely up and to the right. I know the graph kind of looks like it'll stop going up, but no, it actually goes up forever. The domain, this is a discrete question because I know that because it's a table. The domain, that's very easy. It's -1, 0, 3, and 7. And the range is -4, 3, 12, and 29. It's a discrete question. I'm going to erase everything because I want you to watch the video and not just get the answers at the end. So the next one, if you put it into the calculator, and it will tell you the answer. So this is g of x is equal to 3 times 5 to the x power. This is a exponential function, and if you put it into the calculator, it's going to go up really super fast. It's going to look something like that. But that's kind of irrelevant. If you go to the table, you'll notice that x can be anything. So the x in this case is all real numbers. Then the range in this case has a starting point of 3. So that means 0 is 3, which is right there. It's a starting point of 3, and it's increasing by multiplying by 5 each time. So the range actually has a asymptote, and I believe its asymptote is at 2. So I think g of x can be anything that is greater than or equal to 2. Now, I apologize if this one's incorrect because this one I'm not positive of. I need a calculator. I don't have one handy on me right here. What I would do is I would put this into the calculator, and then I want to press second table, look at the table, and see how the numbers are increasing. And I believe, I wrote or equal to. It shouldn't be or equal to. It should just be greater than 2. All right, so it'll be 3 here, and it'll keep going down, but it'll never hit 2 because it has an asymptote at 2. All right, thanks again for watching, and if you have any questions, as always, just see me, and I'll be glad to help. Sorry this video was a little bit long.